for joining. So let's start with a recap of what we did on Tuesday. Okay, so we are in the topic of rectilinear kinematics, erratic motion, where we already looked at this example where this is a bus that travels from Duam to UMPSA, and and we and we assume that this is in the bus moves in a linear motion. Okay, so again, this is an assumption. We assume that the bus moves in a linear motion. And we also look at these three types of plots. We have this one, the first one on the right side, where this is a constant. This is what it looks like. What for y equals to a, constant value, and then it's a linear plot, and then the left one is a quadratic plot. And if we have a quadratic function such as this one, when we differentiate by t dt, we will get a linear plot, linear graph, a linear function. And when we differentiate linear function, we'll get a constant. And if we differentiate this constant, we will get 0. Okay. So if you have an SC graph and you differentiate, you will get a VT graph, which is a linear graph. And if you have a VT graph and you differentiate, you will get an AT graph. Okay, sorry. The VT graph does not need to be linear. It depends on the type of plot that you have. So if a VT graph is, okay, I do not want to confuse you now. So this is basically what it looks like. If you have a quadratic function and you differentiate, you'll get a linear function. And if you differentiate linear function, you'll get a constant. If you differentiate constant, you'll get 0. And the same goes the other way around. If you have a constant function, you integrate, you'll get a linear function. And you have a linear function, you integrate, you get a quadratic function. Okay. And okay, this is what I did not explain to you last week, but I'll do a very quick explanation. Okay. So let's say, okay, okay, I'll just look at this. Okay, let's say you have okay. Okay, let's say you have this let's not look at this for now. Okay. Okay. Let's take a look at this function 4t squared plus 2t plus 2. Okay, so this function, when you draw it in this plot, ST plot, you will get this line, this curve. All right, so this curve is expressed by this function s equals to 4t squared plus 2t plus 2. Okay, you can see the y-intercept here, 2. Okay, so in this case, for t equals to 2, okay, when t equals to 2, which is this one, okay, for t equals to 2, and you'll get this point here, right here, okay? So when t equals to 2, s equals to 4 times 2 squared plus 2t, 2 times 2, plus 2. So you'll get 4 times 4, 16 plus 4 plus 2, you'll get 22. So this number here is 22. Okay, so this is 22. Okay, so if you have any question, you can ask in the chat box in Microsoft Teams, and If you understand what I'm talking about right now, give me a thumbs up, because I cannot see you. I don't know if you can understand or you're listening or not. Give me a thumbs up. You can if you're following what I'm talking about. Okay. So, okay, so this is we're talking about this point right here, this specific point right here, this point, okay, this point t equals to 2, and when you substitute t equals to 2 in this equation, you'll get s equals to 22, okay? So if we differentiate s by t, so we get ds dt equals to 8t plus 2, okay? If we differentiate the ds by t, so we'll get ds dt equals to 8t plus 2. This equation right here, okay? And let's take a look at this point again. At t equals to 2, which is this point, ds dt will equal to 8 times 2 plus 2 equals to 18. 16 plus 2, which is 18. So you'll get 18. Okay, so ds dt equals to 18. Okay, what does this 8 number value 18, what does it represent? Can anyone tell me? You can just write it in the chat area. What does this number 18 represent?
dy dx equals to 8, dx per dt is 18, sir.
Yeah, okay. Yes, it's not dy dx, it's ds dt. Okay, we don't use y and x anymore. It's ds dt equals to 18. Yes, you're correct. But the value represents gradient, just like what Chiu Min Him wrote in the chat box. So it represents gradient. But gradient of what? Can someone explain more? What gradient? What gradient does it represent? Although I already wrote it here. It's the gradient of a line, this line, that is tangent to the curve at the point, at this point, at this point. See, this line, is a straight line that is tangent to the curve at point t equals to 2. And the gradient of this line, the gradient of this tangent line, okay, if we take the delta y, delta x, this is not delta y, delta x, I just wrote this in terms that something that you are familiar with. So if we take the gradient delta s, delta t, that delta s divided by delta t, you will get 18. Right, so it's the gradient of this tangent line that touches t equals to 2, that touches the curve at t equals to 2. So this is what we did just now. Okay, can you if you understand this, give me a thumbs up. So thank you. So it is represented by this straight line here. Okay, this straight line, this straight line, and the gradient of this straight line that touches only that touches the curve only at this point t equals 2 is 18. Okay, and because this is ds dt, ds dt is the velocity v. So what it means that at this point, at point t equals to 2, at this point, at exactly this point, only this point, at t equals to 2, the gradient of this tangent line is given by 18, and this value represents the velocity of this particle only at this point, only at this moment. Okay? So, if you, this is only at t equals to 2, right? But this is a function, see? This is a function. Is 8t plus 2. So you can calculate the gradient at t equals to 3, okay? Which is 16, sorry, which is 26. 26. This is t equals to 3. So at this point, which I will show you after this, you'll get 26, and then the other one, you'll get 34. So what you will get is like this. You see? At t equals to 2, this is the point, and this is the line where the gradient is 18. Okay? This is based on this equation, the velocity equation, or dsdt. And for t equals to 3, right here, this is the straight line that we're talking about. The gradient is 26. And then you have at t equals to 4, which is this one, okay? The gradient of this line, which is the tangent line that touches this curve exactly at t equals to 4, the gradient is 34. So you can see that the gradient is increasing. It means that the slope gets steeper and steeper. Okay, the slope here gets much more steeper, which is exactly what is happening. So when you plot this value, 18, 26, 34, this is what it looks like. Okay, if you plot this in terms of VT, okay, and this is ST, this is ST. If you plot this, you take this value here right just now, the gradient here, and you plot it here, and you grab this here, and you plot it here, and you grab this here, and you plot it here. You'll get a straight line, and this straight line for this VT graph is this equation, 8t plus 2. Okay, why does this happen? Because if you have a quadratic function, which is the function that we have for s, and we differentiate, st graph will become vt graph, and it will be a linear graph. So that's why this curve, quadratic function, will become a linear function, which is the function, this function right here. All right. So this is exactly what it says in this slide. So you can take this gradient at all these points, this gradient here, gradient this point, gradient this point, gradient this point, and you plot the gradient value here, you'll get this another, you'll get the VT graph. Okay, if you are still following me, give me a thumbs up, please. Okay, thank you. Any question?
So far, no, sir.
Okay, thank you. Don't worry, we'll not, this is online, I will not take 2 hours. We'll do some exercise and then we call it day, okay? Now, let's take a look at one example. Okay, this example here. Oh, sorry, we did this, right? Did we discuss this during class? Let's do this one. Okay, let's do this one. Okay, can you see the whiteboard? You can see the whiteboard. Give me a thumbs up.
Yes, sir. We can see, sir.
Okay, thank you. So let's try this question. Okay, as usual, we'll start by just you skim the question first. The car in figure, this figure starts from rest. Okay, let's mark some important information. Starts from rest is a very important statement, and travels along a straight track such that it accelerates at 10 meters per second square for 10 seconds. Okay, a straight track. This is also a very important question. Important, not question, but important information. And then decelerates at 2 meters per second square. Draw the VT and ST graph. Okay, this is what we need to find, VT and ST graph, and determine the time needed to stop the car, the time T prime needed to stop the car. How far has the car traveled? How far has the car traveled? Okay, so these are all information that we have. First, as usual, we will write initial, final, and others, but for in this case, we don't let's just write this range. Okay, the first one is t between 0 right here to 10, 0 seconds to 10 seconds. This is first one, and then we have t between 10 seconds to t prime second. Okay, this t prime is not referring to differentiation. It's just the name of this unknown time where the car stops. Okay, so we don't have any idea yet what this t prime represents. Okay, and the plot that we have is an AT plot. Okay, now let's write down the information that we have. It starts from rest. It means that at t equals to 0, this is starting point, the initial point. From rest means that v at the initial point at point, let's call this point 1, this is point 2, this is point 3. So v at point 1 equals to 0 meter per second. Okay, let's call this point 1. This is point 1, this is point 2. So this is also point 2 at t equals 10 seconds, and this is point 3. Okay, so to make it easier to analyze, let's just break this down to point 1, point 2, and point 3. So from this information, we know that at point 1, the velocity is 0 at the initial point. And then we also know that at t prime, okay, at t prime, and we don't know how what t prime is yet. Velocity is 0. How do we know this? From this statement. Determine the time t prime needed to stop the car. So the car stops at t prime. So velocity v3 equals to 0. Okay. So now let's also write down what we need to find. First we need to find the vt plot, the st plot, t prime, and also S3. S3 is the distance the car traveled. These are the 4 items that we need to find. Okay. Okay. And then what else? Okay, and then from 0 to 10 seconds, what we know is the car accelerates at 10 meter per second square. So A equals to 10 meter per second square. Okay, 10 meter per second square. And from 10 at the second range, 10 to at A2, 10 to t prime seconds, the car decelerates at 2 meters per second square. Decelerates means that it is slowing down. So A equals to negative 2 meter per second square. Okay. So acceleration is pecutan. Deceleration is opposite of pecutan, yaitu pecutan, negative acceleration. Okay, so these are all the information that we have. Good. Thumbs up if you don't have any question. I see someone give me a middle finger. Anyone give me a middle finger? No? Okay. You can still see the whiteboard, right? Yeah, right? Okay.
Yes, sir.
Let's move this. Okay, let's move this a little bit to this side. Okay. Now, what we have is A. Okay. This is how we look at this. What we have is A, and okay, look at this range, 10 to 0 to 10 seconds and 10 to t prime seconds. What is the type of graph that we have here? Not the type of graph, but what is it? Is it a constant, or is it something linear, or is it quadratic? Which one? You don't have to say it out loud. You can just write it in the chat box. Which one is it? Is it a constant? Is it linear, or is it quadratic? It's constant, yes. Okay. See, A equals to 10. This is a constant. Okay. A equals to -2. This is also a constant. And we can also see this in the plot. See, it's a straight line. A equals to 10. And then for the second range, A equals to -2. They're both constants. Constant for both ranges. So, from that, it makes it easier, but the steps are the same even if they are not constants. Okay, so let's start with the first range from 0 to 10 seconds. Okay, so we start because we have A, so we start with A. A equals to dv dt. And we bring dt up here, we'll get dv equals to A dt. And since A is a constant, so we just write the constant here, dt, and we need to, if we integrate this side, we need to integrate this side too. So we integrate both sides. Okay, we have to integrate both sides because of this symbol, equals to. So when you say something that A equals to B, left equals to right, whatever happens on this side must happen, the same must happen to this side. So because we integrated the left side, we need to also integrate the right side. Okay, so you'll get V equals to 10t plus C. Because we don't have any limits here, we have to add plus C. Okay, so now we need to find C. How can we find C? From the initial condition right here. This is our initial condition. Okay, this is our initial condition. So from the initial condition, at t equals to 0 seconds, V equals to 0 meter per second. So we substitute these values into our equation. We'll get 0 equals to 10 times 0 plus C. So we get C equals to 0. Since we have C equals to 0, we substitute this value here. We will get V equals to 10t plus C. Okay, sorry, plus 10t, no plus C, sorry, because C is 0. So V equals to 10t. And this applies only for 0 to 10 seconds. So we have V equals to 10t. Okay, are you still with me? Thumbs up if you don't have any question. Okay, thank you. And next, okay. Let's erase this. Okay. Now we need to do the same for this one because it's also a constant A. So again, this is for 10 to t prime. Okay, and this applies only to 10 to t prime. So A equals to dv dt again. So we bring dt up, we'll get dv equals to A dt. And A is minus 2, so we have minus 2 dt. And if we integrate the left side, we need to integrate right side. This is integration without limit, so we will have v equals to negative 2, 3 plus c. Okay, now we need to evaluate the initial condition again. But the initial condition is not 0. The initial condition is 10, because we're only dealing with this range between 10 seconds to t prime second. So we need to look at this initial condition. Okay, so but we don't have this value yet. So how can we find this value? We need to be aware that this this time here, this time t equals to 10 is also equal to this time. So what it means is that we can use this to find the velocity at t equals to 10 seconds because it needs to overlap. Because the movement of a particle is continuous. You cannot just jump. The velocity value doesn't jump from one value to another value. It moves smoothly. Okay. So at t equals to 10 seconds, velocity equals to 10 times 10. So we get 100 meter per second. So this is the value that we use here. So at t equals to 10 seconds, v equals to 100 meter per second. So from this value, v is 100 equals to negative 2 times t plus c. So c equals to 100 plus 20, you get 120. And you substitute this value back into this equation, you will get v equals to negative 2t plus 120. Okay, so this is why you cannot just assume that c equals to 0, because c isn't always 0. There are many other times where c is not 0, so you have to do this evaluation every time. You cannot just assume that c will always equal to 0. So this can be written, we write this down here, v equals to negative 2t plus 1 to 0. Okay, any question? Okay, no problem. Okay, now let's continue. Now we have velocity v, okay? So if we were to plot this, here's what we do. So this is v, this is t. You have v from 0 to 10 seconds and 10 to 30 seconds, okay? And so whatever happens on this side, okay, whatever happens on this side will be based on this equation, v equals to 10t. Whatever happens on this side will be based on v equals to negative 2t plus 120. Okay, so that's what we will do. And if we calculate, okay, sorry, this is not 30, okay, this is t prime. We do not know what t prime is yet. So if we calculate, let's calculate first this side at t equals to 0, v equals to 0 meter per second. So it's here, the point is right here. And then at t equals to 10 seconds, V equals to 10 times 10 equals to 100 meter per second. So let's write here 100 meter per second. And this is 10t. 10t means it's a linear graph, linear plot. Okay, linear plot. It's not a linear. Okay, it should be a straight line. I didn't write this. It's very difficult to write it using this digital pen, but it should be a nice line. Okay, and then for the second one, okay, at point t equals to 10, it should be 100. Now we need to find, okay, and we know that at t prime, velocity is 0. So we know that it is like this. So, and this is also a linear plot, linear equation. So you will get a straight line from here to here. Like this. Let's use a ruler. Okay, it is much better. Okay. Okay, so this is what it looks like. Okay. So this is what DT graph looks like. Now, how can we find T prime? So we know that at T prime, the velocity is 0 meter per second. So we just substitute this back into this equation. We'll get 0 equals to negative 2 T prime plus 120. So we'll get T prime equals to negative 120 divided by negative 2. So it is 60 seconds. So T prime is 60 seconds. 60. Right? So we have already solved this VT T prime. Okay, so we need to find these two now. So, okay, so that is why it's very important for you to highlight what you need to find. So you will focus only on the stuff that you actually need to find. Okay, you work from this instead of you just write something and then you don't know what you're writing about. You lose your train of thought in the middle of doing something, and then uh, you'll do a lot of stuff that you don't actually need to do. Okay, now can you guys still hear me? Can you give a thumbs up? Can you hear me? Okay, good. Let's continue. Now to find, now we have this equation, okay? This expression here, V. So we know that from Vt to become St, we need to integrate one more time. So we start with V equals to ds dt. So ds equals to V dt. If we bring this dt up to the left and we integrate one side, we need to integrate both. So this is 10t dt. Okay, and we'll get s equals to 10t squared over 2 plus c. And this can be 5. So s equals to 5t squared plus c. And we need to find the c value. And again, to find c, you have to evaluate the initial condition. Okay, so there's one more thing that I did not mention just now. When at t equals to 0, v1, the velocity at point 1, is 0. The position is also 0. So S1 is equals to is 0 meter. Okay. So S1 is also 0 because it did not mention that it starts at some other position. So we can just assume that S1 is 0. So this is the information that you use at T equals to 0, S equals to 0 meter. So 0 equals to 5 times 0 square plus C. So C equals to 0. When we substitute this here, you will get this equals to 0. So we'll get this equation. S equals to 5T squared. Right? Then we do the same for this side. So V equals to ds dt. And we bring dt up here. So we'll have ds equals to V dt. And then we have to integrate both sides. We'll get V is negative 2t plus 120 dt. So S equals to negative 2t squared over 2 plus 120t plus C. Okay. So we'll get S equals to negative t squared plus 120t plus C. Again, we have to evaluate what C is. And again, the initial condition for this case is at t equals to 10 seconds, right here. Okay, so we can find this using this equation. Okay, so at t equals to 10 seconds, S equals to 5 times 10 squared. So this is 500. Okay, so at t equals 10 seconds, S is 500. And we substitute this into this equation, we'll get 500 minus equals to minus, sorry, let's write this properly, equals to minus 10 square plus 120 times 10 plus C. So C is 500. We bring this to the left side, plus 100 minus 1200. Okay, so we get negative 600. So C is negative 600. So this equation becomes S equals to negative t squared plus 120t minus 600. Okay. So now we have to plot this. Let's plot this here. So this is S, this is T, this is 0 to 10, and this is 10 to 60. It is not so accurate because this scale is not right, but you get the idea. So we have these two segments. Okay. Now at t equals to 0, S is not equal to 0, this point. At t equals to 10 seconds, we already calculated this. S equals to 500 meters. So let's write this here. Let's say this is 500. So right here. Okay, and this is not a linear plot. This is a quadratic function. So it has to have this curve. Since this is a plus 5, we have an S equals to 0 at t equals to 0. We have this kind of curve, the smiling curve like this. Okay. And then on the second part, it's also a quadratic function, and it has a negative, this negative sign here, negative sign. So it does not have a smiling face, but it has it's a frowning kind of curve, right? But we need to find the value. So we already know that the t prime, the end of this plot is at t equals to 60. So at t equals to 60 seconds, s equals to negative 60 square plus 120 times 60 minus 600. And if you calculate this, okay, I'll use my calculator to calculate this. Give me a moment. So S equals to 3000. S equals to 3000. So S equals to 3000. This point. So this is what it looks like. So this is too linear. Hold on. No. It's a frowning face like this. Okay. This is not the most accurate representation of the plot, but this is what it looks like. Okay. So okay, don't forget the unit. So at t equals to 60 seconds, S is 3000 meters. Okay, so we already plotted ST graph, and also we already found S3. Okay, so any question? Can you give me a thumbs up if you understood? Okay, thank you. Let's take a look at the answer if we did this correctly. Okay, so yes, 0 to 60, and S is 3000, and this is what it looks like. All right. Okay. So, okay, for this one, there's one more question. Uh, this is VS graph. So this is much more difficult. And you have the answer for this. Okay, so you have to try this by yourself, and you can compare it to the answer that's given. When you do this kind of exercises, don't look at the answer before you try it. Okay, you have to try it without looking at the answer, and then when you're done, you compare it. That's the best way to study, not just look at the answer and doing it alongside the answer. That it will not help you at all. Okay. Let's move on to another question. Okay, let's do a much more simpler question. Mm, We'll do or three more questions, and then we'll finish the class, okay? So, this simple one. The particle travels along a straight track such that its position is described by this ST graph. Okay, again, highlight the important points, straight track. So it moves in straight line. So this is a rectilinear motion. Construct the VT graph for the same time interval. So we need to construct the VT graph. So this is similar to the one we did just now. So we have the first part, 0 to 6 seconds. And then we have 6 to 10 seconds. Okay. But this time we have two different type of plot. The first one is S equals to 0.5 t cubed. The second one is S equals to 108. So this is not a quadratic function, this is a third order polynomial equation, but it's the same. Okay, you don't have to worry about this. And you have this one. And then we have all this information, okay? For example, this one and this point. So this point is at this point, okay? Let's call this point 1, point 2, and this is point 3. So at point 1, we have at t equals to 1 sec, at t equals to 0 second, at the initial point, t equals to 0 second, s equals to 0 meter. And point 2, which is applicable to both ranges, at t equals to 6 seconds, s equals to 108 meters. Okay, so it's applicable to both. Okay, and then since we need to find the VT graph, we know that from ST to become VT, we just need to differentiate. So that's what we will do. V equals to ds dt. So this is a differentiation of 0.5 t cubed by t. So V is 1.5. Okay, let's do this properly, step by step. 0.5 times 3 t squared. Okay, and so we get 1.5 t squared. And for this one, V equals to ds dt equals to d dt of a constant value 108. So this is equal to 0. So this is what we get. So now we need to plot this. Okay, let's plot this here. So this is from 0 to 6 seconds and 6 to 10 seconds. Okay, so this is our VT graph. So from 0 to 6, we have this expression, this equation. Okay, so at t equals to 0 second, v equals to 1.5 times 0 square equals to 0 meter per second. So the initial point starts here, 0. And then at t equals to 6 seconds, v equals to 1.5 times 6 squared. So we have 36 plus 18, uh, 54 meter per second. Okay. 54 meter per second. I think this is correct. So at this point, we have 54 meter per second. So this is the point. And since this is a quadratic function with a smiley face, so it looks like this. Let's make it much more obvious. Like this. And then for the second part, v equals to 0. So it goes down and goes straight like this. This. So this is what it looks like. So it moves from 0 to 54, and then from 6 to 10 is 0. The velocity is 0. So this is the VT graph of this this SD graph. Okay. Why do you get 0? Because from 6 to 10 seconds, the particle stays at one place at s equals 10, s equals to 108. It means that it did not move anywhere. So there's no velocity. The velocity equals to 0. Okay, any question?
No, sir.
Okay. Okay, let's try one more question. Last one. Okay. Now let's try this question. Okay. Bicycle travels along a straight road where its velocity is described by the Vs graph. Okay. This is a bit more tricky because it is not your standard V, ST, VT, or AT graph. It's a VS graph. The x-axis is given by the position S and the y-axis V. Construct the AS graph for the same interval. Okay. Now let's try this one. You try this first. I'll give you 10 minutes. You can also take a break for 10 minutes. Try this, and then we'll discuss after 10 minutes. Okay. Please try this. I cannot see you. So, but if you like to be able to understand this, please try, and then we'll discuss in 10 minutes. Okay, let's start. Okay, let us try this question. So again, the bicycle travels along a straight road. This is a very important information, a straight road. So it shows that it indicates that this is a rectilinear motion problem. So it's a problem where a particle moves along a straight line. Okay. So the best way is to sketch particle and draw a straight line. So it gives you some indicator what it looks like. So the velocity is described by this graph, Vs graph. And there's this equation V equals to 0.25 s. Okay. So construct the same AS graph. So you need to find the AS graph. This is actually very simple, but you have to remember the third equation that we have. If you remember, we have S, and then we have V equals to ds dt, then A equals to dv dt. Okay. So if you remember, we did this where we find this from this equation, we get dt is ds over v. And then from this equation, we get dt is equal to dv over a. And because these are both dt, we can write this like ds over v is equal to dv over a. This is what we get. And we rearrange this, we get a ds equals to v dv. So this is the equation that we can use for this problem. Okay. So since we need to find a, so we write this down, a ds equals to v dv. Okay. And then this is what we need to find. Okay. We have v as a function of s. Okay, v as a function of s. So if we write this down, a ds equals to 0.25 s dv. Okay, and we integrate this. Can we do this right? Is this correct? Can anyone tell me? Is this the right way to do this? Anyone? Does this make sense?
No,
It does
sir.
make sense? No?
No.
Yeah, okay. So I agree with you. Okay, take a look at this, okay? So remember, this is S, but we do not have any S in here. This is A. We cannot do this, right? Remember the rule for integration. And then we can only do this if A is constant, and we do not know if A is constant. So we cannot do this. Same goes here. This is V, but inside here we don't have any V. We have S. We have a constant, but we have S. So we cannot do this, right? So this is not the right approach. What we can do is, because we have V as a function of S, okay, it means that, and we'd like to find A, so what we need to find is A. So if we take S to this side, we'll get A equals to V dV ds. This is what we get. And dV ds, can we perform dV ds? Yes, because we have V in as a function of S. Okay, so if we take dV ds, we'll get V ds of V, and V is 0.25 S. So we have S here and S here. It means that we can perform this differentiation, we'll get V times 0.25. And V is given by 0.25 S times 0.25. Okay. This is V. This is V is equal to 0.25. So we will get 0.25 times 0.25 is 1 over 16. Okay. 1 over 16 times S. So A is 1 over 16 times S. Why do I get 1 over 16? Because this is 1, 0.25 is 1 over 4. So we have 1 over 4 times 1 over 4. So it becomes 1 over 16 S. So this is our equation. This is our equation that we can use to plot this graph. So now if we draw this, this is A, this is S. So 0 to 40. Okay. So from this equation, at S equals to 0 meter, A equals to 1 over 16 times 0 equals to 0. So this is the first point. Don't forget the unit, meter per second squared. Okay. So this is the first point. And at S equals to 40 meters, A equals to 1 over 16 times. So we'll have 4, we get 4, 5. So we have 5 divided by 4. So this is 1.25. So A equals to 1.25. 25. Okay, right here. And since this equation is a linear equation, we can draw a straight line. Let's use a ruler. So this is the chart that we get. It's a linear chart. Okay. Level. Is this correct? Did anyone check? Oh, sorry, this is 5 divided by 2, not 4. This is 2. 2. 5 divided by 2. So this is 2.5, not 1.25. Sorry, I made a calculation mistake. This is 2.5. Okay. But the chart is correct. Okay, if there's no question, give me a thumbs up, please. Okay. You know what? Let's try one more question. Last one. Let's try one more question. And let's try this one. because we have to, okay. A van travels along a straight road with a velocity. Okay, again, let's highlight important parts of the question. It's traveling along a straight road. So this is an indicator that says that this is a rectilinear problem, rectilinear motion problem. Okay, with the velocity described by the graph. Okay, this v equals to negative 4t plus 80. During the construct the ST graph. So we like to find the ST graph and AT graph. ST and AT graph during the same period and take S equals to 0 when T equals to 0. So this is the information that we have at T equals to 0 second, S equals to 0 meter. And at the same time, the velocity, okay, this is in feet per second. Let's change this to meter per second to make it easier. So at the same time, V initially is 80 meter per second from this value. All right. So the expression is V equals to negative 4t plus 80. Right. So this is quite straightforward. Since we are given a VT graph, we know if we differentiate, we'll get AT graph. And if we integrate, we'll get the ST graph. So this is differentiation. This is integration. So this is what we will do. Let's find the AT graph first. So A equals to dV dt, and we take, so this is d dt, this is differentiation, okay, differentiation, d dt of V, which is negative 4t plus 80. So we'll get negative 4. Negative 4. So A is negative 4 meter per second square. So if we plot this, A is negative 4 meter per second square. And it's just a straight line because the value is constant. The value does not change with time. Right? So this is what it looks like. So this is the AT graph. And for the ST graph, we will do the same, but we need to integrate. So V equals to ds dt, and we bring the dt to this part, we'll get ds equals to V dt, and we can integrate both sides, we'll get ds equals to negative 4t plus 80 dt, integration off, and we'll have s equals to negative 4t squared divided by 2 plus att plus c. And we need to evaluate the initial condition to find c, and the initial condition is given here. So at t equals to 0 second, s equals to 0 meters, you'll get 0 equals to negative 2 times 0 squared plus 80 times 0 plus c. So c equals to 0. So we substitute that here, we will get s equals to negative 2t squared plus 80t. So this is what we need to plot. So if we draw this chart, this plot, this is st. And since we know that the initial position starts here at 0, and then at t equals to 20, okay, we have to calculate this at t equals to 20 seconds. S equals to -2 times 20 squared plus 80 times 20. So we'll get negative 800 plus 1600. So you have 800. So S equals to 800 meters. And this is a quadratic function with negative value for A, for the first constant, okay, -2. So the chart will look like this. Okay. So this is the ST graph. Right? Any question? Okay, so this is the end for rectilinear motion, erratic motion. We have many different exercises that you can try for yourself, and if you have any question, you can discuss with me, and we can discuss this during class or outside the lecture time, no problem. But you have tried and ask me questions if you have any. So you have no question, can you give a thumbs up? Or do you have any questions, Abdul Wafi? Any question?
Doktor, yang hari ni doktor akan hantar dekat kalam ke? Yang ajar hari ni?
Dah ada dekat kalam. Semua dah upload.
Oh, dekat kalam.
Semua yang kita panggil semua dah ada di kalam. Lagi? Any other question? Tak ada? Okay. Kalau tak ada, we end this class here and I'll see you next week ataupun next week by online lah. Okay? Okay, terima kasih. Terima kasih. Assalamualaikum and bye-bye. I'll see you next week online, okay? And happy Deepavali to those who celebrate.
Thank you, sir.
Thank you, sir.
You say.
Thank you, sir.
Yes, sir.